In this question, we're asked to determine the most likely ion formed by several different metals and nonmetals, and then to determine whether they're cations or anions. Well, in the first case, scandium 3+, we already know that it has a 3+ charge, so therefore we know that it's a cation, or a positively charged ion. In the case of beryllium, we need to find it on the periodic table, and beryllium is here. You may have learned in your class that the A group number, 1A, 2A, 3A, 4A, 5A, 6A, 7A, and 8A, tells you the number of outermost or valence electrons that an element has. You may have also learned that elements in group 8A, called the noble gases, or group 18, are the noble gases, and these are particularly unreactive. So many other compounds, many other atoms, will lose electrons or gain electrons, so they can have an electron configuration similar to a noble gas. So in the case of beryllium, which is in group 2A, to be like a noble gas, it can lose 2 electrons and be like helium, its 2 valence electrons, or it can gain 6 electrons to be like neon. It is very unstable for something to have a 6- charge. Therefore, beryllium would much prefer to lose 2 electrons. In fact, anything in group 2A will have a +2 charge. Anything in group 1A will have a +1 charge, as it forms ionic compounds. I should note that hydrogen doesn't often form ionic compounds, although they're not impossible. In covalent compounds, this is not the case. So, since beryllium is in 2A, it will form a +2 charge, and we get Be2+, which is a cation. Rubidium. Rubidium is in group 1A, so it can lose 1 electron and have 36 electrons like krypton. So it will lose that valence electron, and we'll end up with Rb+, which is a cation. For nonmetals over here in groups 5A, 6A, and 7A, it's easier for them to gain electrons to be noble gas-like. So nonmetals in group 5A can gain 3 electrons to be like neon, as opposed to losing 5 electrons, in the case of nitrogen, to be like helium. So they tend to form compounds with -3 charges. Group 6A, or 16, -2 charges, and group 7A, or 17, -1 charges, because they want to gain electrons to be noble gas-like. So the question asks us about sulfur. Sulfur is in group 16, or 6A, so it wants to gain 2 electrons to be like argon. Therefore, the stable ion is S2-, because it's a negatively charged ion, it's an anion. Chlorine is in group 17, or 7A, therefore it wants to gain 1 electron to be like argon, and what you end up with is Cl-. Cl- is again a negatively charged ion, which is an anion.